So this is the basic electronics of the CNC. Involves the power supply. This is the unit that takes signal from the computer and converts it into stepper pulses for the motors. These are just motherboards here. They eliminate a lot of wiring. Without them, I'd have to wire all of these connections here to each individual one of these. With them, all I do is take this cable here, attach it to this one, then this one is daisy-chainable to that one, and everything's wired other than out to the motors. For the motor connection, there's a little plastic connector that comes off of here, and I'll show you on the other side of that. This is the inside of the electrical box. I got all of the plug-in connectors in place. This is the connection that I was talking about. This just simply plugs into the motherboard that jumps off of the main board. And I had to wire them all, but they're all wired exactly the same, so it was a pretty quick task. It's nice because it comes with such a long tail that I can just plug it right into the machine, and I can also pull the panel out without having to disconnect in some circumstances. This is some sort of alarm. It came with the box. I may plug that in. Pretty much the alarm would go off when it gets some kind of error, or when it's the end of the cycle. This is just a LED light. These are the plug-in connectors at the outside of the box. They're each 4-pin connectors. It's for the pulse and direction sent to the motors. I have 5 locations here. I figured my X, my 2 Ys, a Z, and a B. I didn't drill for the C-axis just because I don't see that happening anytime soon, and worst case I'll put another connector in. From the case it goes to these cables here. They're pretty long cables. I haven't gotten the energy chain kit in yet. I'm going to order that at the end of the week. That will allow the cables to move along with the gantry, and it eliminates them from being cut. Pretty much, I ordered the motors, which were pre-wired for this connector. Shows up here, and it makes the install pretty clean. For the opposite Y-axis, I just ran the cable down through the center of the 80/20 extrusion. I'll also need an energy chain to span the X-axis as well. This is a base that I machined out of a 2x4. It's just a mock-up, so I'm going to go back and remachine it after. A couple of things I have to change on it, but overall it went pretty well. Pretty much I sank in here so the heat sink bottomed out on it. And then I created these channels so that way the heat sinks could only fit within those, so they can only move side to side. And then for underneath, I hollowed out an area that was big enough for the fan, and that locks it in side to side. When they're installed, on the end, which looks pretty rough as it's only the prototype, but it's got clearance underneath the entire distance, so it will be pulling in cold air from here. Also, it will pull in cold air from any of the heat sinks that aren't running, so you'll also get some free cooling out of that, because even if it's not hot enough to make the fan run, it's just going to shut the fans down, and then you will also be drawing air out of the unpowered fans, so it'll be traveling in that way and pulling out, so you'll still get some kind of supplemental cooling out of those. This is the machine that I've been machining the heat sink supports from. I also did a test wine rack that still in the works. Pretty much I just screwed the 2x4 in. I machined the flat area just to make sure that it laid flat on the table. Did a pretty good job machining it. Definitely not the fastest machine. Can't really push it too hard, but it's still fun to have.